Okay, so these are some properties that we've kind of just assumed. Oh no. Actually, you see keys over there by chance? Okay. Okay, good luck. Thanks. Okay, so these are some things that we've kind of assumed through the process. But if you are adding or subtracting inside of your integral, you can break it up into two separate antiderivatives. That's what you did in number 2 here. You did 3 separate antiderivatives. We just didn't actually write it out. But I want you to know formally that it is okay to do that. I also want you to know that if there is a constant multiplied inside of your integral, you can bring it outside and worry about the antiderivative, then multiply by the constant. I'll let you write that down and then I'll show you what I mean. Like I said, these are things that we've all kind of just done anyway, but we're making it formal. Okay, here's what I mean by that constant. Here we have the antiderivative of 5x squared. It is okay to move the 5 out in front, okay, and just worry about x squared. The antiderivative of x squared is 1/3 x cubed plus c. Then we can multiply by that 5. Now, yes, technically we would have that 5 times everything. But 5/3 x cubed, what is 5 times a constant? It's still a constant. So we don't really assign a value to that constant. It's just plus c. Now, Jesus asked me on Friday, will we ever find c? When we get back from winter break, we'll go through examples. I will give you a coordinate on f of x so that we can find a particular solution to the antiderivative. There are a lot of curves that would match this description, but I could give you a coordinate from f of x and then we find c. But we'll worry about that till after break. Okay. So don't write these down. We talked about these on Friday. The antiderivative of 0 is just a constant. The antiderivative of k would be kx plus c. And then the power rule, we increase the exponent by 1 and then multiply by its reciprocal plus c. Okay? As we talked about in our problem of the day, please do not forget to rewrite these before actually taking the antiderivative. So I'm going to give you a beefed up example. Go ahead and write this one down, please. There is no such thing as a quotient rule for antiderivatives. Antiderivatives, we are very limited to what we can do. Okay, I'll just tell you that up front. Some of the strategies you won't even learn until next year if you take a second year of calculus. Okay, so what are we going to have to do? We're going to have to rewrite this. So basically, we're going to have to divide everything by x squared. Our first term would become what? X minus 5 I guess I'll just do that one. Plus x to the what power? Minus 7 x to the negative second. That is how we would do that rewriting. Don't forget that we subtract our exponents when we are dividing. Okay. Now, do we have 5 individual power rules, essentially? We do. We can take the antiderivative one term at a time. X becomes 1/2 x squared. Negative 5 would become, what, Eli? Negative 5x. X to the negative 3/2. Callie, what would we do with that? Negative 2x to the negative 1/2, so our exponent's negative 1, multiplied by its reciprocal, negative 2. All right, and then negative 7x to the negative second. April, what would that become? Good. We have to increase the power by 1, which means we go to negative 1. Divide by negative 1 would make it become a positive 7. And then don't forget your lovely plus c. It is fine for you to leave your answer like that, or you can rewrite it to where there's no negative exponents. It really doesn't bother me one way or the other. But don't try to make it look like the original. You don't want to try to find common denominator or anything. We'll just leave it like this. Okay. All right. Ready for some trig?
No.
Okay, we're going to go through all of the antiderivatives. What I would do if I were you is I would write down what I have in red. What I have in black is prepping you to think about what the antiderivatives will be. You already figured out 2 of them on Friday, so these first 2 will be a refresher. Okay? We know that the derivative of sine is cosine. So what is the antiderivative of cosine? Sine. Okay? Plus c. Just write down what I'm writing in red. The antiderivative of cosine of x is sine of x plus c. Okay. Then we know that the derivative of cosine is negative sine. So if we're trying to take the antiderivative of sine, what would we get? Negative cosine. You got to keep those negatives straight. Okay, they're backwards now. CJ, what's the derivative of tangent? Secant squared. Derivative of tangent is secant squared x. So if we want the antiderivative of secant squared x, that would be tangent of x. We are not going to worry. I'm sorry. I'm getting there. I'm getting there. And there's just a glare. We're not going to worry about secant of x. That's not something that we will learn this year. We'll worry about it next year. Okay. But what is the derivative of secant? We do know that. Secant tangent. So if we have the antiderivative of secant x tangent x, we know that that is secant x. Okay. 2 more. What is the derivative of cosecant? Say louder. Who was whispering back there? Negative cosecant cotangent. The derivative of cosecant is negative cosecant cotangent. So if I have the antiderivative of cosecant cotangent, it would be negative. Let me see that that's a negative. I better rewrite that. Negative cosecant. In my opinion, if you know your derivatives, you should know your antiderivatives. Okay? If you know one, I think you can get the other. But these plus the next one we do are all ones that need to be up here, not only for tomorrow, but for next semester. Okay? Last but not least, the derivative of cotangent is negative cosecant squared. So if we have the antiderivative of cosecant squared, that will be negative cotangent. Okay, so we need to be able to apply these with our antiderivatives. Once again, we cannot take an antiderivative unless it looks like one of these or with numbers inside or outside. Okay, and I'll show you what I mean. First example I want to look at is this, the antiderivative of cosine of 7x dx. What did we write down the antiderivative of cosine to be? Sine, okay? However, since there's a 7x inside, we better keep the 7x inside. If I take the derivative of sine of 7x, do we get cosine of 7x? No, we need to account for what rule for derivatives?
Chain rule.
The chain rule we need to think about. So if we go backwards, right, our chain rule, if we took the derivative of this, we would have to multiply by 7. So we need a 1/7 in front. It's kind of like the anti-chain. It's not called a name, but we have to just think about that chain rule happening if we were to go backwards. Does that make sense? Let's think of another one. Okay, if I had the antiderivative of sine of 4x,
-1.
Trevor is very quick to tell me -1/4 cosine of 4x plus c. Do you agree? Okay, awesome. Next one. Did you say that's an equal one? What did you say?
No, nothing. It's
Did you say it was equal?
no.
Oh, okay, that's good. It's not that bad. Okay, now it looks a little different because you see thetas instead of x's. Sometimes you'll see that, especially when we're working with trig functions. Okay, if you need to write them as x's, you do what you need to do, but since we have this d theta right here, it's telling us to take the antiderivative with respect to theta. Okay, so we'll do one thing at a time. All right, the antiderivative of theta. Okay, good. We increase the power by 1 and multiply by its reciprocal. Minus the antiderivative of sine is what, Brett? Okay, so negative cosine of theta. minus cosecant squared of 3 theta. So first of all, Henry, what was the antiderivative for just cosecant squared? Okay, so negative cotangent, keep the angle the same, but since our angle has a 3 times theta, we would need to multiply by 1/3. Please do not forget your plus. Anybody have a question?
Yes, no. Okay, no worries.
Okay. Glad I. Okay. One more trig example here. Okay. Are we going to take the antiderivative right now? No. That would be silly. Okay. We need to rewrite it into functions that we are more familiar with to take antiderivatives of. So, cosecant, or excuse me, cosine cubed divided by cosine squared would reduce to what? Plus sine over cosine squared. We could do a tangent. Sine over cosine is tangent. Okay. So here I'm going to write this one over here. So we could write this as sine over cosine, but then we would have an extra cosine in the denominator, right? And what's 1 over cosine? Secant. So this would be secant v tangent v. dv. Is this so much better? It looks super complicated, but with just a few trig identities, we can get it to something that we can take the antiderivative of. Okay? Antiderivative of cosine? Sine. And antiderivative of secant tangent?
Plus v.
Okay. Two more rules, two more basic rules. I will remind you. What is the easiest rule ever in differentiation? Differentiation. What's the easiest derivative rule that we have?
Power rule.
I would argue that there's one even more simple.
Oh, yeah.
What's the derivative of e to the x?
Yes.
E to the x. What's the antiderivative of e to the x?
Wow.
Plus c. Yes. Okay. Derivative e to the x, antiderivative e to the x. Okay. Easy one to remember, right? Yeah. Only thing you're gonna have to be careful of is when you have. Will we say numbers? Numbers. Okay. Like this, the antiderivative of e to the negative 2x. Okay, might as well just say copy paste. Yeah, it's our copy paste rule, right? So the derivative of e to the x is e to the x, so we copy paste. But since we have that negative 2 inside, we would have to multiply by the reciprocal to account for the chain rule if we were to go backwards. Let's see. You can always check yourself. If you take the derivative of your answer, do you get what is inside? If we take this derivative, do we get e to the negative 2x? Then we're correct. Okay. Okay, next one. Can we take the antiderivative right now? No, we need to rewrite so we have individual terms without any of this division stuff. Okay? Well, if we take 5 divided by e to the 2x, very good, 5e to the negative 2x. Okay? We want to write e, we don't want e in the denominator. We need to bring it up for sure, so we just write it as a negative exponent. Minus e to the x divided by e to the 2x would be e to the negative x. We subtract those. All right, so when we take the antiderivative, we have 5 times the antiderivative. So copy paste, but since then we have that negative 2 multiplied inside, we need to account for that chain rule. Okay, and same thing here. Minus the derivative of e to the x is e to the x, so we're going to do our copy paste. But since there's a negative 1 multiplied to the x, we're going to have to account for the chain rule, and that becomes positive. This is a good way to reinforce derivatives by thinking about how to go backwards. Okay, that'll help if we start reviewing. Second place tomorrow. Okay. All right. We have one more rule to talk about. And I've avoided anything with this for this reason. But if we had 1 over x inside of an integral, what would happen if we tried to use the power rule? We get x to the 0. That doesn't make sense, right? If only we had something that when we took a derivative, it was 1 over the natural log. Here's the last rule we're going to talk about. The antiderivative of 1 over x is the natural log of the absolute value of x plus c. Why an absolute value? We can't take a natural log of a negative number, so when we take the antiderivative, we account for that. It has to be after that. Okay, so we're going to do 1, 2, maybe 3. Maybe 4. We'll do 2 to 4 examples, and then we'll be done. 2. 2? You probably want more than 2. Okay, so this is one, you may want to write this as 7 times the integral 1 over x dx so that you can clearly see what rule you need to do. Okay, so this antiderivative would be 7 times the natural log of the absolute value of x plus. That seems simple, right? As long as you have a linear denominator, you can still use the natural log rule. The antiderivative of 1 over x is the natural log of x. the antiderivative of 1 over x minus 5 would be the natural log of x minus 5 plus c. That only works if it's linear. If it's 1 over x squared, we use the power rule. Okay? Actually, what do we have to do before we take the antiderivative?
Get the denominator out.
Okay, we need individual terms, right? So we have x divided by x squared. X to the x divided by x squared. X to the negative 1. Plus 2 times x to the negative second. Okay? So now we can use the power rule, right? Does power rule work on x to the negative first? No, but I need you to recognize that x to the negative first is the same as 1 over x, which means its antiderivative is natural log of x. Okay? Now we can use the power rule because we have an exponent that's not negative 1. We increase the exponent and multiply by its reciprocal. So minus 2x to the negative 1 plus c. Okay, so give me 1 second here because I forgot the page number. Okay, I am going to give you a worksheet where you need to cross some out, and I'm also going to give you a couple book problems that you can just do on the back. Okay? So, alright, so I'm going to give you this worksheet. Cross out the first 6 rows. Cross out this second row of 60. 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 Okay, so you have only 9/14 of this top portion. 13 problems that deal with, so the top portion deals with e to the x, bottom portion deals with natural log of x, and then these problems deal with some of the power rule and trig, and you need to practice the trig, okay? So you have kind of a variety of problems to do. Do what you need to. In my opinion, these worksheets go pretty quickly, okay? Are you already laughing at the joke?
It's just the question. It's just,
Oh, you don't have to like do the joke part of it. Yes, you do. Okay. I care about the math part of it. So you guys have like 10 minutes left in class. So maybe you can try to get done a portion of the worksheet or the book portion if you don't want to take your book home or something like that. Okay? We have our quiz tomorrow. So let's do it to it.
I gotta go with someone.